Okay, let's give you guys some more practice. So determine if this series will converge or if it will diverge. So press pause and have a go. Okay, so to do this, we are going to make use of this theorem where it says that the series that you're trying to investigate, well, look at the absolute version of the very same series. If the absolute version converges, then the original thing that you're trying to investigate will also converge. So looking at this, imagine this as being one block multiplying this block. Well, this 2 here is a constant, so you can take it out. So that will then give you this. So now it's saying, so if this, so visualize this as being one block multiplying with another block. If this block here converge, then when you times 2, then the whole thing will converge. Therefore, this will converge. But visualize this as one block multiplying another. So it really boils down to you trying to determine if this will converge. So now make use of this theorem. This is what we're trying to investigate. Well, have a look at the absolute version of the same thing. So have a look at the absolute version of the same thing. Well, remember, absolute of A over B, that's the same as absolute of A over absolute of B. So that will then give you this. Well, this thing here is the same as the number 1 because you've got 1, negative 1, 1, negative 1, 1. When you take the absolute, it will always be 1. And then well, n is moving from 1 to infinity, so this will always be positive. So when you take an absolute of the positive of something that's always positive, then it will remain as always positive. So really it boils down to us looking at this. So looking at this, because this contains n factorial, then think about the ratio test. So apply the ratio test on this. So applying the ratio test, we always need to compute this value here. So we always need to compute this value here. It's saying get the next term divided by the current term. So an plus 1 is this. Remember, we are trying to determine this now. So if we are trying to determine this, so looking at n plus 1, an plus 1 will be this over n plus 1 factorial. So looking at an plus 1, that will then give us this. Divided by this, that's the same as you multiplying with the reciprocal of an, which will be this. So now tidy this up. So rewrite this as n plus 1 times n factorial. Now these two will cancel out, giving you this. So you can see that as n increases, as n tends to infinity, then the limit will be 0. So the limit of this thing being 0, looking at the original theory, the limit equals 0. So the limit here is, well, equals 0. So this is less than 1. So therefore the series will converge. Okay, so our series are, well, this thing here will converge. We've looked at the absolute version of this, which is this thing here. Well, we've just established that it converges. So using this theorem, the theorem saying if the absolute version converges, then the original series will converge, meaning this will converge. Well, if this will converge, then therefore this will converge. So our original series will converge. Okay.